Number 6, according to the Bohr model, or according to Niels Bohr himself, which is the point in the figure below where electrons cannot reside? And in the notes, we saw this central nucleus with concentric circles around it. And we saw electrons inhabiting either concentric circle. Okay, we said that they can transition from one concentric circle, one principal quantum number, to the other, but we said that they actually never inhabit this middle ground. Okay, they kind of teleport or transport themselves into the next energy level. Okay, they simply jump. There truly is no transition. They're just in n equals 1, and then they're in n equals 2. So let's apply this to the solar system model. Okay, this is our solar system. We got a star, and we got a couple of different orbits here. But then we notice here, in between the orbit of planet B and planet D, we have this notation for C. Notice that each of these planets is on a specific orbit. Okay, we use the term orbit when we're talking about celestial bodies revolving around a particular star or other object. But these are different orbits, and each of these three items, these three planets, are on their specific orbit. Okay, and they're going to stay on that orbit. C is not in any one particular orbit, it's in between. Okay, and that would put it in between these different n values. N is equal to 1, n is equal to 2. We just said that electrons cannot inhabit this middle ground in here. And so it would be true to say, if we assume that this A planet here, this orbit, is n is equal to 1. The next out for B would be n equals 2. And then D here is n equal to 3. B is on n equals 2. Okay, n equals 2. And D is on n equals 3. You can't have an electron in between 2 and 3. You either have to be in main energy level n equal 2, or main energy level n is equal to 3. You can't be in between. And so we see that point C is not a location where electrons can reside.